This is a screencast using Newton's second law to solve a problem. Pat pulls on a box to the right with a force of 8 newtons. Friction acts on the box with a force of 3 newtons to the left. These forces cause an acceleration of 2 meters per second squared to the right. Find the mass of the box. We would like to use Newton's second law to solve this. To use Newton's second law, we need the net force on the box. The net force is the combination of the two forces acting on the box. Pat's force is to the right. We'll take that to be positive, and the friction force is to the left. We'll take that to be negative. Since these two forces are acting in opposite directions, that causes a subtraction in the setup of the equation. So we have the net force is Pat's force plus a negative friction force, or minus the friction force, plugging in the numbers. That would be 8 newtons, Pat's force, minus 3 newtons, the friction force. When we do the subtraction, we get 5 newtons. That answer is positive, which says that the net force is to the right. Now we're ready to use Newton's second law. Newton's second law says that the net external force acting on an object is the mass of the object times its acceleration. We want to solve for the mass of the object, so we can divide both sides of the equation by the acceleration. That allows the acceleration to cancel on the right side of the equation, and we get the net force on the box divided by its acceleration is its mass. Now we can plug in the numbers. The net force was 5 newtons. The acceleration was 2 meters per second squared. And then when we divide, we get 2.5. Let's take a close look at the units. We have newtons divided by meters per second squared. Recall from the textbook that a newton is equivalent to a kilogram, meter per second squared, and so we still have to divide that by meters per second squared. Now we can see that the meters per second squared cancel out, and we're left with kilograms. That says that the units on our answer should be kilograms, and kilograms is an appropriate unit for mass, and so we're fairly sure we did the problem correctly.